So Hamza, let's start.
Sir, I'll come back after 10 minutes. I have to go and pray.
Okay. Okay.
Okay, sir.
You are in now. Should
Yes,
should I should I start?
yes, sir.
So Hamza, how are you? So I have discussed about the capacitor. Is my voice is clear? Hamza, is my voice I am audible?
Yes, sir.
Okay, okay, fine. So I have told you about the capacitors. Capacitors are nothing but the combination of two conductors and which are separated by some medium, and the capacitor is used to store the charge. And we will study three types of capacitors, and mostly we will study this parallel plate capacitor mostly. Okay, and after that spherical capacitor and cylindrical capacitors, and we have also completed this numerical. Now I am moving forward. So today I am going to start with question that battery and capacitor both stores charge. What is the difference between two? What is the difference between two? Okay, so we know that uh, in our phone there is a small battery, lithium battery, and we charge that battery with the help of charger. This thing we know very well. Means we charge the battery, and in the same way we charge the capacitor. Like battery, we charge the capacitor. So during charging, both behave same. Means there is nothing, there is no difference in the charging of capacitor or the charging of battery. Okay, like we charge our phones in the same way we charge the capacitors by connecting some power source. But during discharging, during discharging, what happens? Now let's see during discharging in battery what happens. In our phone, there is a battery, and we know that the discharging of our phone takes time. Means the discharging of our phone, or you can say the discharging of your phone's battery discharges gradually. Okay, means the battery discharges gradually, means slowly. Gradually. Okay, no problem. For example, you can say battery of your phone. And another I can say, like suppose this is a bulb and this bulb is connected with a battery. Okay, this is a battery. This is the symbol of bulb in physics, in electricity. And this bulb glows constantly. Okay. Glows constantly, and the discharging of the discharging of battery takes place gradually, and accordingly the bulb behaves. Okay. But now, if I talk about the capacitor, if I talk about the capacitor, discharges instantaneously. Discharges instantaneously, or you can say with, within a fraction of second. An example you can take, like the flashlight of your camera. Once you turn on the switch of the flashlight, it turns on immediately, and it gives all its energy at a particular of time. Okay. And after that, all the energy is all the energy is finished, the glows disappears. Okay. Means you can say the bulb of that flashlight is connected to the capacitor. Okay. So capacitor discharges instantaneously within a fraction of second. It will lose all its energy, but battery will lose its energy gradually. Okay. Understood, Hamza? Hamza?
Yes, sir.
Okay. Should I move
Yes, sir.
forward? Okay. So you can take the screenshot of this first. Then we will start the new topic. Or if you want to note, then you can note also. Completed? Hamza, completed?
Yes, sir.
Okay. So now we will start parallel plate capacitor. parallel plate capacitor. So as the name is suggesting, parallel plate, there are two parallel plates will be there, like this you can say. Here is one plate. I don't know what is happening. Okay, not. This is one plate and this is another plate. And these two plates have equal area. And why I am saying these plates are parallel, because these plates placed parallel. And one plate is positively charged and another plate is negatively charged, as we have discussed. Earlier we have conductors, now we have conducting plates. Now we have conducting plates. Actually this plate is not looking good, but no problem, you can imagine. Are these plates are looking parallel or not? Hamza, look here. These plates are like this. Okay, this is one plate, this is another plate, like this. Please imagine these plates like this. Not working. It is okay. So this has the area A. This plate also has the area A. This has minus sigma. This has plus sigma. And this plate have positive charge and this plate have negative charge. And distance between these two plates are like this. And Hamza, please note that these plates are like this. Okay, these are plate. This is a like hand. You can imagine these as a plates. These plates are like this. This is one plate and this is another plate. Okay. In the diagram, these are not looking correctly. And the distance between these two plates is D. Please have patience. Okay, no problem. And we can move this here also. Okay, now it's okay. Let's see. We have two parallel plates. This is one plate, this is another plate, and this have a positive charge and this has a negative charge. Okay, this has a positive charge and this has a negative charge. And the distance between these two plates is d. And sigma is surface charge density. Surface charge density, and sigma is equal to charge upon area. Charge on any plate upon area. And this plate has -q charge and this plate has +q charge. And for your understanding, I want to tell you one very interesting thing. Suppose this is one plate. Now I am drawing the front view of the front view means like this. Your eyes are looking on the screen like this. Okay, so you will see two lines like this. So this is, suppose this is positively charged plate and this is negatively charged plate. And Hamza, I want to calculate the electric field here. I want to calculate the electric field here, and this has been studied by you in the chapter electric field, or you can say Gauss law. Maybe your previous teacher have taught this thing, but that's not a problem. I will tell you. So suppose if I want to find the direction of electric field due to both these plates. Suppose this is plate 1, this is plate 2. So Hamza, please tell me at this point, where is the direction of electric field? In this direction or in this direction? The direction of electric field due to this plate at this point. In which direction? Is it correct? Hamza? You can,
Yes, sir.
Okay, fine. Why it is correct? If you want to calculate the direction of electric field at any point, consider there a positive charge. And this is a negatively charged plate, means due to this will attract this. So due to this, the electric field is in this direction, and due to this plate, this is positive and this is positive, this will repel, means the direction of electric field E1. And we also have studied that due to these due to any plate, whether having a positive charge or negative charge, the value of electric field at any point is equal to sigma y epsilon naught, if sigma is the surface charge density of this plate. This is the formula that you have studied in the chapter electric charges and fields. Okay, so please remember this. Electric field due to any one plate is equal to sigma y epsilon naught. And same is the case with negatively charged plate. So here E1 is equal to E2. This E1 and E2 will be equal, and these are equal to sigma by epsilon naught. Okay, so please remember this formula. Please remember this. So it means that here this E1 is equal and this E1 is equal, means you can say there is a point. There is a point here, and someone is stretching this pen in this direction with a force F, and another person is stretching this pen in this direction with equal force. So net force will be 0. So means here two vectors are in opposite direction and they are equal also. Means the net electric field at this point O will be 0. So we can say outside the plates of the capacitor, the electric field is 0. Electric field is 0. So this is just for your understanding. This is very beautiful concept. So that is why na capacitor has formed. Capacitor, what is the, why we have made capacitor? How what is the work? Means to confine the electric field in a region. Means there is no electric field outside the plates. The electric field will exist between the plates only. This is the device we have made. So now suppose if I want to here the electric field is 0. Here also the electric field is 0. We know that very well. I have proved here electric field will be 0. And here also electric field will be 0 due to these both the plates. But what if I am calculating the electric field here between any point between these plates? Like these are the two plates, and between any, I take a point between these plates, and if I want to calculate the value of electric field or direction of electric field, what will be that? So this is negatively charged plate, means I have told you that if you want to calculate the value of electric field, consider a positive charge at that point. So due to this negatively charged plate, the direction of electric field will be like this. Suppose this is plate 1, this is plate 2, and due to this positively charged plate, what is the direction of electric field, Hamza? Hamza, can you tell me? You can message, you can write in chat box also.
Sir, can you say again?
What?
Sir, can you say again?
Okay, sorry. Actually, can you please tell me, the direction of electric field, at this point due to this plate?
So it will be towards the right.
Okay, very good. Means if I am supposing this electric field due to this plate as E1, so E2 will also be in this direction. Okay. So at point O, Hamza, if you have not understood, if you are not understanding my words sometimes, then please ask me. Okay. This is the direction of E1, and again this is E2, means two vectors, and I have already told you the value of E1 and E2 is equal to sigma y epsilon naught. The value of E1 and E2 will be sigma y epsilon naught. I am not taking this negative because these are vectors. In scalar, we take things with sign. Okay, like in the case of potential energy. So if I want to calculate the net electric field at point O means I will add both the electric field like E1 plus E2, and sorry, I made a mistake. The value of electric field due to any of the plate will be sigma by 2 epsilon naught. So this will be sigma by 2 epsilon naught plus this will be sigma by 2 epsilon naught, and E net will become sigma by epsilon. Net electric field at point O becomes sigma by epsilon. And we have a formula of potential between plates, that is B. We have the relation between the electric field and potential, like electric field is equal to potential by D. Okay, electric field is equal to potential by D. Like you can compare from here, E is equal to minus dV by dr. So this is the form of this. Okay, so E equal to potential by dr for distance. And I can write this equation as V equal to E into D. So this will be E net at O into distance. Distance between two plates. And now we have the potential V equal to E net means sigma by epsilon naught and D. And I have written the value of sigma also. So sigma will become Q by A. This is the value of sigma, and this is epsilon naught, and this is D. So we have potential, value of potential as QD divided by A epsilon naught. You can consider this as equation 1. And we know that the capacitance is equal to charge divided by potential. Charge, what is the charge here? Charge is Q. Magnitude of charge is Q. And potential is QD divided by A epsilon naught. Q and Q cancel. Then you will get the value of C as epsilon naught A divided by D. So finally we got the answer epsilon naught A by D. This is the capacitance of parallel plate capacitor. You should remember this formula. That's how we calculate. Hamza, fine na?
Yes, sir.
Have you understood na? Actually, one thing I want to tell you, this thing is little bit complicated for you. Maybe you have forgotten these things, but no problem, that's fine. Everyone forgot the things. I also forgot some things. But now I am telling that you should remember outside the plates, the electric field will be 0. But inside there will be electric field. And the value of that electric field will be sigma by 2 epsilon naught due to each plate. And total electric field will be sigma by epsilon naught. And what we have done, we have this formula. We have this formula. And I have write this equation in this form. and this is total electric field. Here E is total electric field. Total electric field between plates, and this is potential between plates, as I've already represented this, so no need of representation. And sigma is the surface charge density. Surface charge density. Charge upon area. If you have any doubt, then please ask me and please note it down. And please try to speak. Hamza, have you completed this?
Yes, sir.
Okay. So you can say that I have completed now. Can I speak? Completed? Are you writing or taking screenshots?
Sir, taking screenshot.
Okay. Then done na?
Sir.
Done till here?
Yes, sir.
Okay. So this is the capacitance of parallel plate capacitor. Parallel plate capacitor when air is in between the plates. So in between the plates, the medium is air. Like here, in between these two hands, there is air. And I will represent this C with C naught. C naught means capacitance of parallel plate capacitor when air is filled in between the plates. So C will be, I am replacing C with C naught. You can write this as C naught also. And C naught is epsilon naught A by D. And epsilon naught is absolute permittivity of this thing. Have you studied this thing now? In the previous classes, there was I think there was another teacher na, who told you about the electric field and charges. So sigma naught is known as permittivity of air. Absolute permittivity of air. D is the distance between two plates, and A is the area. A represent area of plate, and both plates are of equal area. Now we have this formula, and you should remember this. So from here I can say this C naught is depends on area and distance, means the shape and size, means I can say depends on geometry of capacitor. Geometry means shape and size. Okay. So now this is the first case when air is in between plates. And now we will calculate the capacitance when in between the plates there is some another medium. So Hamza, you can see here, like these are two plates. These are two plates. Look here. These are two plates, and right now the air is in between these two plates. But I can replace this air by some other medium like oil. I can put these plates in oil. I can put these plates in water. Okay. I can place these plates in dielectric. Okay. Now I need these plates. So now let's see. Two plates having area, surface charge density, charge, distance. This is plate 1, this is plate 2. Everything is same. But this time when dielectric is fully filled, in between plates. Now, in between these plates, the dielectric is filled completely. The dielectric is filled completely. And then also the electric field outside the plate will be zero. Whether you fill dielectric or some other medium or air, electric field outside the plate will always be zero. And if I want to calculate the electric field here, now here is dielectric. Here is dielectric. And their medium is dielectric. Dielectric is something which is a non-conductor. Dielectric is insulating material. Dielectric is insulating material. Hamza, what are insulators? Okay. Insulators are those which cannot conduct electricity. Okay. Means there are no free electrons in insulators. So if I want to calculate the electric field at this point now, but this point is now in dielectric, means everything here in this space is dielectric now. If I want to calculate the electric field, so direction of electric field due to this plate will be like this. You can say E1, direction of E1 and E2 will not change. But the value of E1 and E2 will change this time. Now the value of E1 will become sigma divided by K epsilon naught. And K is dielectric constant of medium. This has been studied in electric field, charges and electric field. After the Coulomb's law, there is a topic known as dielectric constant. Dielectric constant. This is dielectric constant. So E1 and E2 will be same in magnitude, sigma by K epsilon naught. And these are in same direction. At point, if I am drawing the electric field at point O, this is a point O, na? At point O, this is point O. If I want to, this is E1, and again in this direction is E2. So simply two vectors are in same direction. Two vectors are in same direction. We can add them directly. We can add them directly. If these two vectors are in opposite direction, so we can subtract them. Okay. So E net electric field at point O is equal to E1 plus E2, and the value of E1 is sigma y. And why I am forgetting this? Due to each plate, the value of electric field will be sigma y 2k epsilon naught. Earlier it was sigma y 2 epsilon naught. Now this time k is multiplied. So I have written this 2k epsilon. Nothing has changed except k. So here sigma y 2k epsilon naught plus sigma by, oh sorry, there is a test also, 2k epsilon naught. So E net at point O will be sigma by k epsilon naught. And we have the formula, and I can write this ED and V equal to E is sigma by k epsilon naught, and D I can write sigma as charge upon a k epsilon naught into D. This is the value of potential. Potential is now QD divided by Ka epsilon naught. This is equation 1. And capacitance is charge divided by potential. Now charge is charge Q. Potential is Q D divided by Ka epsilon naught, and Q cancel. We will get C K epsilon naught A divided by D. So I am representing this C epsilon naught A by D. So I am writing this C as Cm. Cm stand for capacitance in medium. K epsilon naught A divided by D. This is the final formula. This is the final formula, and I can write this Cm as this. What is this? This is C naught, na? K into C naught. So don't remember this formula. No need. Only remember this formula and write the value of C naught. Okay, this is important for your examination point of view. So Hamza, here K is always greater than or equal to 1. You can say K is greater than 1, equal to 1 for air. So if K is greater than 1, then Cm should be greater than, Cm must be greater than C naught. Okay. Now please note it down. This is the case when dielectric is placed. Please note it down, and after that we have a test of half an hour. Please note it down and hope you have understood. Hamza, noted? Hamza,
Yes, sir.
noted na? You can you can
Yes.
you can text me also na on the chat box.
Yes, sir.
This is completed. Completed na?
Yes, sir.
Okay. Till here completed.
Yes.
Okay. So this is all about the we have studied parallel plate capacitors when air is in between plates, and we got the formula C naught epsilon naught A by D is the area of plate, and after that when medium is in between the plate fully filled, we got this formula Cm is equal to Kc naught, and K is always greater than 1, and K is equal to 1 for water. So now let's move to the next part of this. Please try to solve these questions and send me the pic or the PDF on the group. Okay? Are you ready? These are very easy questions. Hamza, do you have mobile phone right now?
Yes, sir.
So what should you should write these the answer of this question and snap that, and you can send me that on the group. Okay?
Okay, I'll send.
And these are very easy questions, not very hard questions. And these questions will help you in your board examination also.
Yes.
So please continue. And please try to be honest. When completed, I am here. You can send me.
Sir, I sent the answers. Sir, I sent the answers.
Okay, have you completed now?
Sir, I sent the answers on chat.
You have sent on the chat. You should send on the group. We have a group now.
Yes, sir, but I cannot send because my father is not here.
Your answers are good. No problem. You have not completed the first question?
No, sir, I don't know that.
Okay, no problem. Give me a minute. Actually, Hamza, this is a subjective test. You should also try to draw the equipotential surfaces. Your answer is right, and it will be 0. This is also right. And when the angle will be in the electric dipole, the moment has to be 180 degrees. Okay, and Hamza, now do you have any doubt
Yes, sir, the first question.
in the first question? Na? Okay, this is your test now, and after the result of this test, we will discuss this question. Actually, this question is very simple question. I have already told you. Okay.
Sir, I forgot.
Okay, no problem. That's not a problem. I will tell you this question in the next class. Okay. And in the previous lectures, in the previous classes, if you have any doubt, then you can ask me. Like, if I want to ask you that, what is charge? Do you know what is charge? CHARGE, charge. First chapter. Charge is a property of matter. Charge is a intrinsic property of matter due to which electric field, electric force, electric energy is produced. And secondly, do you know what is matter? So tell
No,
me
sir, I
what is
cannot
matter?
say the exact definition of it.
Okay, no, that's not a problem. That's not a problem. I am saying if you not you cannot say the exact word, but at least you should try now. Please try. Please tell me. No problem. What is matter? Try to speak, Hamza. In life, there will be the time when you have to speak in front of
Yes, sir.
thousands of people. In front of not me, in front of thousands of people. Okay.
Sir, something that has length, height, breadth. Maybe it's a
Yeah,
substance.
you are right. You are right.
It has mass, maybe.
Huh. Okay, you are right. Actually, Hamza, I am telling you one thing. Please remember this thing. In front of your teacher, like you speak a lot in. I know that you will speak a lot with your friends. I do so. And please, when in class, when you are interactive, it will be good for me or for you also. Okay. Please try to speak. And there will be the time in your life, believe me, after the 12th class, you have to do something. Not maybe you will choose the engineering or something else. This physics is not for your life, not for your life. This physics you are studying for improving your mind, for improving your mentality, for improving your thinking. In life, physics is not important. The important thing is that how to deal with the situations and the conditions that you will face in your further life. Suppose, what do you want to become in your life?
Not planned yet, sir.
Not planned. Means when, suppose if you want to become an sports person, suppose a sports person you want to become. If you want to go in sports, then also you have to do the work. Then also you have lot of challenges in when you will go in sports. And there should be the purpose of this life that is given by Allah. We know that very well. Okay. And
Yes, sir.
uh, there is a purpose that we came in this world. We so we should follow Allah also, and we should follow the things around us for your life. Those things are important, are important. I am not saying that physics is very, very important thing. This is just a part of your life. And if you are doing anything, if you are doing anything, please try to give your best. No matter if you are weak in that, no matter if you are strong in that. And one thing more, I want to tell you that I believe best are not those who give the best. Best are those who tried their best. Okay. So this is the thing. As I am engineer by profession, I am a mechanical engineer, but I am teaching physics. Okay. So, but you should at least learn how to do hard work, how to learn the things. Okay. And take your life seriously and become sincere in your studies. Okay. Because this is the part of your life.
Yes, sir.
Okay. So these are the things that makes you a human. Our class is of 1 hour and 30 minutes. So if you have to sit in the class for 1 hour and 30 minutes, so try to give your best. And after that, what you are doing, no problem. Try to give your best at least, and try to revise the notes, and try at least try to learn the things. And you have given the good answers. Means if you are having a in a day, if you are having 10 hours, Suppose if you are having 10 hours. So you can give at least 2 or 3 hours to your study, and in the remaining hours, in the remaining 7 hours, you can do anything that you want. Do you like TV series or movies, Hamza?
Yes, sometimes.
Do you like Marvel movies?
No.
Okay, fine. Means you like movies or TV series, and that's thing. Why you like? Why you like? Because you are get interested in that, you know. So I also like movies,
Hmm.
but the thing is that your study is also equally important.
Yes, sir.
So this is the, maybe I am teaching you the physics or someone else will teach to you. No matter. Today I am here. Maybe tomorrow someone else will be there. So that's not a. Uh, but you should at least try. Okay. We have 2 more minutes. Do you know about? Do you have you heard about the name of the scientist Newton?
Yes.
Do you heard uh, about Albert Einstein,
Yes.
Stephen Hawking,
Yes.
Nikola Tesla?
Yes.
Very good. Always try to give your best. So, Hamza, we have 1 more minute left, and please try to understand the value of time. Time is very important. In Quran also there is one surah about the time. I have forgotten. Um, so time is very important. So please try to be sincere. You are a good student. I know. And if you have any doubt, you can ask me. Yeah? You can ask me. There is no problem. I will be very happy. There is no student that asks me doubt except one student.